Simplifying and expanding polynomial expressions. To simplify and expand polynomial expressions, there's some important properties we should know about multiplication. First one we're going to talk about real quickly is the commutative property. Multiplication is commutative. So what does that mean? It means that the order of the operands when you're multiplying does not change the result. So the operands might be A times B, but the order I put them in doesn't matter. It's the same thing as B times A. So for example, if you multiplied 2 times 3, it's the same thing as 3 times 2. You can change the order of the operands. So the operands are the things that we're multiplying. Likewise, when we're multiplying polynomial expressions, you can rearrange the order. So if I have 2x minus 3 times, 2x plus 1, it's the same thing as if I rearranged it and made it 2x plus 1 times 2x minus 3. So remember, you can rearrange your expression anytime you like. So if you're simplifying something and you think to yourself, it would be a lot easier if I rewrote this in a different order, you can do that. That's called being commutative. The next property is the associative property. The associative property generally states that the order you multiply things in doesn't really matter. It won't change the results you get. So if I'm multiplying 3 terms or 3 operands together, A times B times C, I can really multiply them in any order I want. I could start by multiplying A times B and then multiply it by C. Or it would be the same thing as if I decided to multiply B times C first. The order doesn't matter. It's up to me. So how can we use that when we're multiplying polynomials? Well, let's say we have an expression like 2x minus 1 times 3x plus 4 times 5x minus 7. I can choose what order I multiply these together. So maybe I want to multiply the first two together. 2x minus 1 times 3x plus 4. Maybe I'd prefer to multiply the last two together. 3x plus 4 times 5x minus 7. I could even multiply the first and the last. And then, using the property we just learned, the commutative property, I can also rearrange this and write it in any order I want. So remember, when you're attempting to simplify an expression, you choose which sets of terms you want to multiply together first. So again, if you want to rewrite this and put the 3x plus 4 out front, you can do that. You can put them in any order and multiply any group together that you want first, as long as it's all multiplication. And that's the associative property. The third property we'll discuss is the distributive property. That's something you're probably pretty familiar with it at this point. Distributive property says that multiplying a sum or difference by a number is the same as multiplying each term within the bracket by that number and then adding and subtracting the result. So what that basically means is if I could add a plus b right away, or I could multiply by the x on the outside first. So if I multiply by the x on the outside, I'm going to get x times a plus x times b. And that's the distributive property. So the idea is, if I had something on the outside, right, 3 times 2 plus, let's make it a 4, right? Well, I could do it two different ways. I could add the 2 and the 4 and go 3 times 6, right? And 3 times 6 is 18. It's the same thing as if I distributed, let's do this thing again, oops. 3 times 2, 3 times 4, that gives me 6 plus 12, and 6 plus 12 is also 18. So when we're simplifying, we can distribute. Okay, let's start by multiplying a binomial times a binomial. So think about it. There are 1, 2, 3, 4 terms here. 5x is a term, minus 1 is a term, 2x is a term, and positive 7 is a term. So there are 4 terms. In each bracket, there are 2 terms. So what we're really doing is we're taking 2 terms here, multiplying it by 2 terms here. So 2 times 2 is 4. So when we multiply 2 terms by 2 terms, we should always get out 4 terms. So some of you might have used something called FOIL, first, outer, inner, last. FOIL, first, outer, inner, last, as a technique. So the idea is I'm going to take the first term here, the 5x, multiply it by the 2x. Then I'm going to take the first term here, multiply it by the positive 7. So if that would be the outer terms. Then the inner terms, negative 1 times 2x, and then negative 1 times 7. So let's see what that gets us. So when I multiply the first terms, 5x times 2x, 5 times 2 is 10. X times x is x squared. Then the outer terms, 5x times 7 is going to give me 5 times 7 is 35, and x. The inner terms, the negative 1 times the 2x, negative 1 times 2x, negative 1 times 2 is negative 2, and multiplied by the x. And then the last terms, the negative 1 and the 7. So negative 1 times 7 is negative 7. So notice how I got out 4 terms when I multiplied 2 terms by 2 terms. Now in this case, and is often the case with many of these, the 2 terms in the middle can be simplified. You can collect the like terms. So now you always want to, after you've expanded, you want to simplify and look for like terms. So 10x squared has no like terms. 35x minus 2x is plus 33x, and then minus 7. So it's pretty common, those 2 terms in the middle, but that's not always the case, just with some common binomial expansion. So this is what we generally call binomial expansion. It's a binomial times a binomial. A binomial meaning 2 terms. So 1, 2 here, and 1, 2 here. Binomial expansion. Okay, let's look at some shortcuts now for binomial expansion. What we have here is a binomial square. I know it's a binomial because there's 1, 2 terms inside the parentheses or brackets, and it's being squared. So we call this a binomial square. And there's a shortcut to this, but the first thing we want to point out is the number one mistake that students make, which is a lot of students think we just square the first term, square the last term. This is incorrect. So this does not equal what I'm going to write here. This would be the wrong answer. So 3x squared, 3 times 3 is 9, x times x would be x squared, 4 times 4 would be 16. Now I know that looks like it makes sense, but it doesn't. Because remember, what did we say in the previous example? 2 terms times 2 terms. We need to get 4 terms out, and we only got 2 terms out. So what this really means is this. This means we have 3x plus 4 multiplied by 3x plus 4. So it's a binomial multiplied by a binomial. So we need to multiply it and make sure we get 4 terms here. So let's start with 3x times 3x. 3x times 3x, 3 times 3 is 9. X times x is x squared. Now, let's multiply the first term by the last term. 3x times 4 gives me positive 12x. Let's multiply the middle terms together. So 4 times 3 is plus 12x. And then finally, 4 times 4 times 4 is 16. So notice we did get some of those terms we just discussed, but there's 2 additional terms that we were missing. Now notice those 2 additional terms in the middle are like terms again. We can add them together. And that's going to give us 9x squared plus 24x plus 16. Now, here's the catch. There's actually a shortcut to this. And if some shortcuts are more useful than others, but this is a shortcut you really, really should learn. So we call this the binomial square shortcut. So what we just did is a binomial and we squared it. So this works out every single time you multiply a binomial. So look at our case here, a plus b squared. So in this case, the a would be the 3x and the b would be the 4. Well, it works out every single time that when you do a binomial square, you end up squaring the first term in the front, you square the last term in the back, and in the middle, you always get this pattern, 2 times the first term times the last term. So let's see if this makes sense. Let's try and do this with our binomial square. So we had 3x plus 4 squared. So 3x was a. So what did we get when we square a? 3 times 3 is 9. X times x is x squared. The b was 4. So let's put that in the back. B times b, right? 4 times 4 would give me 16. Now in the middle, 2 times a times b. So we would multiply these two together, the 3x times the 4. 3x times 4 is 12x, and multiply it by 2. So essentially we would double it. So 3 times 4 is 12x. Double that gives us positive 24x. Notice over here in our example, the reason why it's doubled, notice you get 2 of the identical term, and that's what you get when you multiply the 3x by the 4. So this works every single time. So let's try applying this to some more examples. All right, so notice we got another binomial square, but in this case there's a minus in the middle instead of a plus. But the same idea applies. You could put a minus in the middle, and what you'd end up getting is a squared in the front still, b squared in the back still. The only difference is in the middle, it would be minus 2 times A times B. So let's do this. In this case, A would be 5x. B would be then minus 3, or in this case, we could just say 3. So let's try this out. Let's square the first term. 5x squared, 5 times 5 is 25, x times x is x squared. Let's square the negative 3 in the back. Negative 3 times negative 3 is positive 9. Now watch what happens when we multiply the 2 in the middle together. What is 5x times negative 3, right? Well, 5x times negative 3, what would that give us? Negative 15x, and then we double it, right? Twice, 2 of them. So if we double it, that's going to give us negative 30. So let's put in the middle, negative 30x. And there you go, binomial expansion. This is one of the most useful shortcuts. I strongly recommend you learn this, memorize this pattern. Okay, so here we have an expression with a little more going on. It would take us a while if we did our traditional expansion. Let's use that shortcut we just learned. So we have a binomial square here and a binomial square here. So let's use our shortcut. So I'm going to leave the 5 on the outside of the bracket here, or the parentheses. And let's do our binomial expansion. So remember, we're going to square the first term. 2x times 2x is 4x squared. Square the last term. Negative 1 times negative 1 is positive 1. Now we multiply the two terms together. Negative 1 times 2x, or 2x times negative 1 is negative 2x, and then double it, negative 4x. See how quick we can do that? Now let's put this minus 3 out front still. Let's do binomial expansion again. Square the first term. 3x times 3x is 9x squared. Square the last term. 4 times 4 is 16, positive 16. Now, multiply the two terms together, which gives me 12x, and then double it, plus 24x. Now, look how quickly we're able to expand that. Now, the rest of it, we're going to have to do a little tidying up. So, we have to take the 5 here and distribute it. Remember our distributive property. Let's distribute, distribute, distribute. So multiply each term inside the bracket by the 5. So that gives us 20x squared minus 20x plus 5. Now, here's where we really want to be careful. A very common mistake made by students is when they distribute, they forget to multiply by the negative. You're not multiplying by 3, you're multiplying by a negative 3 or a minus 3. So we have to also distribute that negative. So when we do that, negative 3 times 9x squared changes the sign to negative 27x squared. Negative 3 times 20 is negative, oops, come on, pen, there we go, negative 72x. And negative 3 times 16 is negative 48. Okay, now we're going to collect up the like terms. So when I do that, I want to add terms that have the same variable with the same exponent on it. So negative 27 x squared and 20x squared, right? You can add and subtract those. So 20x squared minus 27x squared is negative 7x squared. Usually we want to put the term with the highest degree. So usually the one with the highest exponent at the front. So the x squared we're going to put first. All right, let's go negative 20x minus negative 72x. Let's collect those together. So when I add them, negative 20 minus 72 gives me negative 92x. And then finally at the end, we have a positive 5 and a negative 48. Let's add those together. 5 minus 48 gives me negative 43. Now that's fully simplified. We don't want to factor today. We're just simplifying. So that would be my fully simplified answer. And again, we usually like to write it in degree, the highest degree first. So that the x squared has a degree of 1. The x has an invisible, sorry, that is a degree of 2. The x has an invisible degree of 1. Now, technically, you could write x to the power of 0 here. He would have no degree. But we don't want all that extra stuff. We just want to write it like that. Okay, next let's look at a binomial cubed. A little more difficult, but we can take our time. So there is a shortcut to this, but before we look at the shortcut, you might not like it. Again, this is where some students like the shortcuts. Some find the shortcut actually just ends up taking them longer and has more to memorize. But what we want to remember is we have 3 of these binomials to multiply. So it's up to us where we start. Do I want to multiply the first 2 together? Do I want to multiply the last 2 together? It doesn't really matter because they're all the same. Now, another way of looking at this to speed it up is, wait a minute, don't 2 of these make a binomial square? So some students like to do this, and we're just going to write it like that. So This guy would be the power of 1. This would be the power of 2. So some students like to use this. And what we'll do is, let's leave this 2x minus 5 here. And let's do our binomial expansion, right? Our binomial square here. So remember, a plus or minus b, in this case it's a minus b, is going to equal a squared minus 2ab plus b squared. So why don't we do that? It'll help pick things up, speed it up a little. So let's square the first term. 2x times 2x is 4x squared. Let's square the last term. The negative 5 times negative 5 gives us positive 25, so it's always positive in the back. Now, let's multiply these two together. 2x times negative 5 is negative 10x. Double that, negative 20x. So I just saved myself a little bit of time. But now, I still have to multiply what's left. So let's think here. We have 1, 2 terms times 1, 2, 3 terms. So 2 times 3, we have to get out 6 terms here. Okay, so let's start multiplying. Let's start by taking the 2x and multiplying it by each term. So 2x times 4 gives me 8x squared. Oops, 8x cubed because it's 2x times 4x squared. So x times x squared, we add the exponents. 2x times negative 20 is negative 40x squared. And then 2x times 25 is plus 50x. All right, so I've taken the first term and multiplied it by all those terms. Now, let's take the second term, the negative 5, and multiply it by all of them. So negative 5 times negative 4x will give me negative 20x squared. Sorry, negative x squared. Negative 5 times negative 20x gives me positive 100x. And then finally, negative 5 times 25 gives me negative 125. Now you notice I'm starting to get a lot of terms in a big long line here. You can do it this way. Some students, though, like to do this instead. So instead of writing them in big one long line, when I multiply the second set, what I can do is just line it up underneath. So when I do it this way, it allows me to kind of add things up nice and easy. See how I can just kind of add it up. And when I look down, you just add to what's below it. So 8x cubed plus nothing is 8x cubed. Negative 40 minus 20 gives me negative 60x squared. 100 plus 50 gives me 150x. And minus 125. It's the same thing as collecting your like terms if they're in one big long line, but once you start multiplying more and more sets of terms, sometimes it goes a little bit quicker. But again, you could just put them back the way they were. If I get rid of this here, and when you add the like terms, you'll still get the same thing. So you don't have to do this, but it's a method I really like. It keeps things nice and neat. Notice how we still only have the 8x cubed. He's the only one here, right? When I go negative 40x squared minus 20x squared, I still get negative 60x squared. When I take the 50x plus the 100, I still get the 150. And at the end, you have the negative 125. So it's up to you which way you prefer to do it. All right, next we have a binomial cubed again, but let's try it with the shortcut. Now, shortcut with a question mark. Some students love this and they find it's way faster. Some students don't, they find it takes them longer, or they make more mistakes. So be cautious if you're going to use this shortcut. So all of these different binomial expansions, cubed, the power of 4, the power of 5, they all have patterns to them. They're all based off of something called Pascal's triangle. We're not going to get into that in this lesson, maybe another lesson. But it's up to you if you like this or don't like it. So in this case, the 3x would be our a, and b would be the negative or minus 4. So remember, we got to include that negative when we do that. Okay, so let's start by doing a cubed. All right, so a is 3x, and we want to cube it. So 3 cubed, 3 times 3 times 3 is 27. X cubed is x cubed. Next, 3 times a squared times b. Okay, so we go 3 times 3x squared times negative 4. So we got to be careful here, right? Use our calculator or whatnot. So we have to square the 3. So 3 times 3 is 9. Multiply it by 3 and multiply it by the negative 4. When we multiply it all together, we get negative 108. And don't forget, we also have to square the x squared. So there's my next term. Okay, the next one, 3 times a, which is 3x, times b squared. So we want to square the negative and the 4. Keep that square on the outside. So when we do that, right, we're going to go negative 4 squared. That gives me positive 16. 16 times 3 times 3. That's going to give me positive 144. There's no square on our x, so it's just x. And then finally, you get to b cubed, which is what's negative 4 cubed. So be careful. It's 3 negatives. Negative times negative times negative is an odd amount of negatives. So it's negative. 4 times 4 times 4 is 64. And now I've expanded it. Now, is that any faster? Maybe, maybe not than the other method. You kind of have to choose your path. What do you like better? Do you like doing that? Or, again, you could just do this and not memorize a pattern. You could take 3x minus 4 cubed. I'm just going to scroll the screen up a little. Right? And then, oops. And then break it up. I like to break it like this and just think to myself, well, I know how to do a binomial square really quick. Do the binomial square, then do what we did in the last example. So 3x minus 4, right? Square the 3x. 3x times 3x is 9x squared. Multiply the negative 4 times negative 4 in the back, which is positive 16. And then multiply them together, negative 12x, and double it, negative 24x. And then do what I did in the last example. Take this 3x, multiply it by each term. Take the negative 4, multiply it by each term. And once I simplify, I'm going to end up with the exact same answer I got up here. So it's going to be up to you. You either have to memorize this pattern really well if you want to use the binomial cube shortcut, or stick to what we did in the previous example. Okay, a couple more examples. We have a trinomial squared. So let's think about this. Squared, right? And trinomial has 3 terms. 1, 2, 3. So if we have 3 terms squared, right? 3 squared, that's 9 terms. 3 times 3. So we have to get 9 terms of this. So it's getting really messy. It's not difficult. It's just going to test our patience and see how neat and tidy we can be with our work. So remember, this really means this. X squared plus 5x plus 2 times itself. So we got to be careful. That's 3 terms times 3 terms. So we need to get out 9 terms. Okay. So to do that, let's start with the first term. Now, there are some shortcuts to these, but they start getting a little more and more, I don't want to say convoluted, but they get to the point where you may find memorizing and learning all these patterns is more time than just multiplying what's there. So let's take the x squared and multiply it by 1, 2, 3 terms. Okay, so x squared times x squared, add the exponents, x to the 4, x squared times 5x gives me 5x cubed, and x squared times 2 gives me 2x squared. Now, let's go to the next. Let's take the 5x, positive 5x, and multiply it by each of the next 3 terms. So now, we can do what I did before, which is write them in one big long line, or since we're going to have so many terms, sometimes it's a smart idea to write them underneath. So when we go 5x times x squared here, 5 times 1 is 5, x times x squared is x cubed. We could write it back here, but we're going to get a big long line of terms, right? Or we could write it underneath the like term, the other term that has a cube. So we have another 5x cubed. Okay, let's go to the next one. What do we go when we go 5x times 5x? That would give me 25x squared. Let's write it under the other x squared term. And then 5x times 2 would give me plus 10x. So this kind of takes up a little less paper, and I'm not writing in one giant long line, and it's going to make it way easier at the end when I add my like terms. Okay, finally, 2x. So let's take 2x and multiply it by x squared. So 2x squared, let's write it underneath the other x squared terms. 2x times 5 gives me plus 10x, and 2 times 2 gives me plus 4. So now, all 9 of these terms, notice we have 1, 2, 3 here, 4, 5, 6, 7, 8, 9. They'd be in one big long line. But if I line them up, it makes adding together at the end way easier. Okay, so let's add them up. X to the power of 4 has nobody to add, so he'll go there. 5x cubed plus 5x cubed, we just add the coefficients, the numbers in front. 10x cubed, notice I'm not changing the exponent. 25 plus 2 plus 2, that gives me 29x squared. 10 plus 10 gives me 20x. And then finally, the lone positive 4 at the end. So there you go. It wasn't too hard, and by stacking them up, it makes the adding at the end so much easier and way less mistake. Okay, last problem in the video. Let's determine a simplified expression that represents the volume of this. Okay, so volume of a rectangular prism like this is length times width times height. So which side's the length, which side's the width, which side's the height, it actually doesn't really matter. But let's just say the length is x plus 5 here. Okay, x plus 5. We'll say the width is x plus 2. And let's claim the height is x plus 3. Okay, now there you go. There's your length times width times height. Remember, Multiplication is commutative and associative, so it actually doesn't matter which order we put these in. I could scramble this up and go x plus 2 times x plus 3 times x plus 5. I could put it in any order I choose. Whatever I think is the easiest way of multiplying here is the order I'm going to put them in. So you choose the order. So let's just copy this down, and I'm going to move it below the diagram so I have a little more room to work. Okay, so I've just copied down the expression I wrote here. So volume, this is my expression for volume here, equals x plus 2 times x plus 3 times x plus 5. Now it's up to me who I multiply first. You can multiply the first two, the last two, the first times the last, which is a little weird. It's up to you. I always like to multiply the last two together when I do this. And I'll kind of talk about why as I go. Maybe it's just because that's the way my teachers did it. So I'm going to leave the x plus 2 here. So let's multiply. Now, unfortunately, we can't use our binomial square shortcut because these are two different binomials. So we just have to go x times x is x squared. There's no real shortcut here. X times 5 plus 5x. 3 times x plus 3x. And 5 times 3 is plus 15. Now, some of you might do it a little faster than me because a lot of students like to just add the two terms in the middle all at once. So you would end up with plus 8x. Okay, so two terms times two terms gave me 1, 2, 3, 4 terms, but then I collected the like two terms in the middle and I ended up with 1, 2, 3 terms in the end here. So now, what are we going to get? We have two terms over here, right? Times three terms over here. Well, 2 times 3 means we need to get 6 terms out. So we just got to be really careful. So let's get multiplying here. Let's go x times x squared. That's going to give me x cubed. X times 8x gives me 8x squared. And finally, x times 15 plus 15x. Okay, I've taken the first term in the bracket, multiplied all the terms in the second bracket. Let's take the 2x and multiply it. So 2 times x squared gives me plus 2x squared. Now remember, I can write this at the back, or if I want, I could actually write it underneath. Makes collecting it up a little nicer. 2 times 8x is plus 16x, and that's up to you whether you like to do that or not. And then 2 times 15 is plus 30. So you could have these three terms like I have them here, or I could just put them at the back and collect my like terms like that. It's really a personal preference. I like to stack them up because it makes it a little easier at the end. Everything I want to add is already where it needs to be. So let's add these up. X cubed, right, plus nothing, still x cubed. 8x squared plus 2x squared gives me plus 10x squared. 16 plus 15x gives me plus 31x and plus 30. So there's my expression. My square is a little sloppy over here, but there's my expression for the volume of this rectangular prism here. So if we knew what the value of x is, we could sub it in and find it out. Find out the volume.